So we are trying to calculate, show some examples of how to calculate and the forces that structures need to be designed to resist, and a little bit about how we take that force and analyze the structure to do it. This presentation, I want to deal with the impact load due to debris. So we're talking about what kind of a force do I need to resist or design for to consider just this debris impact loading. I'm actually going to use some structure the same as what I did on my previous example. Now I'm only going to talk about an inundation depth of 10 feet. And I actually want to consider three different things the engineer might be trying to determine. They may be trying to determine the moment in the diaphragm. They might be trying to determine the moment in the moment frame. They might be trying to determine the shear at the base of the moment frame. So the simplified alternative method gives me a quick calculation of 268 kips. My I value is 1.25 because it's a toxic material inside. The value of ISO I can look up. And I don't have any knowledge about whether this is a harbor or a port. So I'm going to take the conservative assumption that I can't reduce the force by 50%. So I have a force of 268 kips. I'm trying to determine the moment in the roof diaphragm. The largest moment in that roof diaphragm is going to occur when that force is being applied right in the middle of the width of the building and as high as it possibly could. But the inundation depth of 10 feet means I don't need to consider it occurring all the way at the roof. So if my wall can withstand that 268 kips, that's going to put a point load in the middle of my diaphragm of 192 kips, which will result in the largest moment that this roof diaphragm has to resist. If I'm interested in the moment occurring in the moment frame, well, the worst situation now would be that debris hit right directly in line with my moment frame and at the highest point possible. So I'm going to have to assume that 268 kip force might be applied right at my moment frame, 10 feet away from the base. Now I can analyze this moment frame, simple statics. Since I only have one beam rigidly connected to the column, this is the only column that can resist shear. I can determine the couple to resist the overturning moment. And I can now draw a moment diagram that gives me the largest moment that this column and beam have to resist based upon the impact load. It's important to keep in mind that this is in addition to the hydrodynamic and the hydrostatic forces that are being applied. If I'm interested in the shear at the base, well, then I need to think that, well, that force might be applied right at the very bottom of this column and give me that full force having to be reacted by this single base connection. Now, in reality, in my structure, it's such a simple structure that the reaction is always going to be the force. Doesn't really matter how high it is. But in a more traditional building, I need to think about that force hitting only a single column to foundation connection.